Hi, this is Jonathan Gardner. I'm going to teach a course on electrodynamics. This is what I learned when I went to college and studied as a physics major. This is real electrodynamics. This isn't hand waving and smiles and happiness and pretending you know when you don't know. The book that we're going to use, and you need to get this even though it costs a lot of money, is Introduction to Electrodynamics. This book is written by David J. Griffiths. It's a great book. This is probably the best physics textbook you're ever going to find in your entire life. This is the second edition. The third edition came out shortly after I graduated. And there's a fourth edition coming out soon. You can find the second edition if you really want it. I don't believe there's too much difference between the different versions, and to be honest, you probably could get by without the textbook. You won't be able to do the problems, of course, which I think is a major part of learning how physics actually works, but you'd be able to learn at least some of the principles and remember them. What do you need to know? Well, if you want to learn electrodynamics, you have to be proficient in the following fields. One is algebra. If you don't know algebra, you're just going to be completely lost. I can't emphasize that enough. You really have to go out there and learn algebra, get used to moving those symbols around. Another is calculus, but you'd be surprised how little you actually need to know to get through everything. So if you just understand the ideas of calculus, what the limit, derivative, and the integrals are, that should be enough. The third thing that you're going to need to know is some classical mechanics. Basically what you would pick up in your first year as a physics student, or that physics class you have to take as an engineer. So this is the F equals ma stuff, 1/2 mv squared, some of the rotational kinematics, and some of the basic principles of how physics works. And the reason why you have to take that is you have to understand what mass and velocity and acceleration really mean, and you kind of have to have a feeling for how physicists approach problems versus mathematicians. And the last thing you're going to have to need is you're going to have an open mind. Some of the ideas you're going to learn are completely different than what you think you already know, which is a good thing. When you learn something new, you hopefully eliminate something you thought was true but isn't. So with all of these things, you should be able to do well in this course.
you.